Hi class, I'm using the OBS software again, so let me know if the audio is awful, and I will just stick with Zoom all the time, but OBS is a little bit friendlier for recording videos. We're talking this week about our Week 9 content, working with arrays, and arrays give us a lot of power, a lot of great capabilities. So array structures are variables that hold repeating data, so they allow us to more efficiently save information. We have to allocate an array before it can be used, and all of the entries in a given array must be the same data type. And once we allocate an array, the size of the array cannot be updated, so we have some limitations. So what are we talking about? Well, we're used to creating variables. We know that we can have variables that are integers or strings. We can have decimals and doubles and different things, Booleans, different languages, different data types. So all of these things give us the ability to store information effectively in memory. But sometimes we like to store more than one of a thing. So what if we need to store several different people's names? Well, we could do that with an array. An array gives us the ability to create a collection. So when we're working with an array, first of all, we have a certain syntax that's required to create an array. We'll look at several of those. The array itself is allocated in memory as a list or a collection. We can use an index, which is just an integer value that we can use as a pointer to a specific entry in our array. So index 0 is always the first entry in our array. We always start counting with 0. So Joe here is at index position 0 in our name array. The index value for Tammy's entry is 2. So we would refer to her entry as name square bracket 2, where within the square brackets we have the value of the index. And that could be a variable or whatever we want to use to indicate that value. If we want to update a given entry in an array, we would specify the array name with the index location. For example, name index location 2, and then the equal sign to assign a new value, followed by the new value. So this line of code would update the value in position 2 of our array to new name, so we can see how that works. Notice the syntax here for creating an array. We are allocating or declaring and instantiating our array in one line of code. In this example, we say we want to declare an array of strings. Our string is our data type, and we follow that with the square brackets to indicate this is an array. Then the name of our array, then after the equal sign, the new keyword to indicate we want to instantiate an instance of a string array with 5 different values. So here again we have an array that was declared in code a little bit differently. We, in this case, said we want to declare an array of integers called age, and then we supplied the values that we wanted entered into that array. So this array in memory will look just like this here. The array will be allocated contiguously in memory. That means all of the array must fit together. It's not going to let it be split up into different chunks of memory. The index positions are shown here, and then the values that were assigned to each of those entries in our array. You can see first we had a 16 and a 45 and the 29, the 24 and the 14. So those are the values that got added to our array. Now if we did this code down here where we printed out the entry at position 4, that would print out the 14. If we printed out the entry at position 0, index location 0, that would print out the 16. What would happen if we try to print out the item at index position 5? We don't have an index position 5 in our array, so that would cause an out of bounds exception. That means that we've gone out of the boundaries of our array. So we could see some sort of exception like this. We see our first values printed and then our out of bounds message. Now that syntax is an array with initialization, where we're saying here are the values to supply to the array. The data type that we want to use is followed by the square brackets, then the name of our array, then the initial values that are contained within curly braces and separated by commas. Those initial values will be used to determine the size of the array. Now, the syntax that we use to access an entry in an array is shown here. We declare a variable that we want to use to hold one entry from our array. We set that variable equal to or assign it a value from our array. First, we use our array name, followed by our index pointer, which is always enclosed within the square brackets. And then our one age variable will now hold the value 24 because it is what's at position 3, 0, 1, 2, 3. So don't forget to start counting with 0. Now, if we want to again update the value within an array entry, we specify the array name followed by the index pointer location enclosed within square brackets, and then our assignment operator, the equal sign, and then the new value that we want to assign to that position in our array. So that would set our position index pointer to position from 29 to 28. So we'll hear people or programmers discuss walking the array or looping through the array or traversing the array. What they mean is executing some sort of loop code to check all of the entries within an array or do some sort of processing. So here we have our integer array named age. At the top we have the index values for the different positions within our array, and then in the gray we have the actual values that is contained within the array. So if we had some code like this for loop where we wanted to print out each entry in the array, this would be very effective. So we're saying in our for loop we want to allocate an integer. We want to call it I. We want to give it an initial value of 0. We want to execute our loop while I is less than the length of our age array. So the length property is a special property that's available to us through the array class. And that length property will return to us the number of entries in an array. Now notice our length is going to be the number of entries. So it would start counting at 1, 1, 2, 3, 4, 5. Versus our index locations, which start counting at 0. So sometimes in our code we have to make accommodations for that, where we can encounter an off by 1 error. Now in this for loop again, we're going to control the loop and run it until we've executed it one time for every entry in our array. So our counter has reached the length of the array. Every time that we execute this loop, we want to update our counter I. And then we're going to print out the value that's encountered with a space. So we should see that as we execute this for loop, we're going to look at the value at each location in our array, printing that out as we go, and then we'll see our final output would be all of those entries. So just going to process each array in our loop, each array entry. So we can also use an enhanced for loop or the for each loop. And the for each loop or enhanced for loop allows us to use some special syntax to traverse our array. So again, here we have our age array that has been preloaded with these specific integers. Let's set this up. It's being weird. Oh, I know why. I'm going to break my presentation here. Duh. So as we work with this for loop, we're going to say that each item that is in our array should be referred to by the name entry. And each of those items is going to be an integer. And we want to traverse the array named age. So notice the syntax here. We use the keyword for, and then we have parentheses. Within our parentheses, we specify a data type for each item in our array and give it a name as this for loop is being processed. Then we have the colon character followed by the name of our array. So as this for loop is processed, this is a visual of how we'll see, or how our program will see, each of those entries. Internally, we'll look at the first entry, and this 16 will be processed by our code under the name entry. So we'll print out that 16, then we'll go to the next entry, and we'll print out that 45. Then the next entry, we'll print out a 29, next entry, and the next entry. So the key here is, to my weird visual, notice that only the entry that we're looking at is available while we're using the enhanced for loop. It's very handy, it works great, but we only see that one item that we're being given at this point as we're processing. So we can't back up and look at previous items or look forward or have access to our index value. But it is a very, very handy way for us to process each entry in a collection. So the syntax, oops, it's not the keyword for each, it's the word for, sorry, C# left over. So the keyword for, I better fix that, huh? Let's fix it because it's too messed up. I'll show you how easy it is to switch int entry between C# and Java. There we go. Now we're Java. So our syntax is for each entry in the loop, I will be processing an integer. Each integer will be named entry, and the array that I want to process is following the colon. I will fix that before I save it so you can get the revised version. Now we also have a REPL course. Look, I left C# on this one too. Oh no! But you guys have a REPL course also for working with arrays. Now a couple of other items here when we're working with arrays. Sometimes the limitation of one data type can be a problem for us. For example, what if I need to keep track of employee IDs or ages along with their names? We know that an array can only hold one data type, so I could end up needing to use what's called parallel arrays. And parallel arrays are just two arrays that are kept in sync. So for example, in this situation, if I have these two arrays, one called age and one called name, I would know that index entry 0 of the name array matches the entry 0 of the age array. So I know Joe is 16. I'll keep that data in sync and keep these arrays in parallel. Bill is 45, our new name person is 29, Vera 24, Austin is 14. So that's parallel arrays, and I have to do a little bit more processing, but not too awfully bad. When we work with methods in Java, we pass data back and forth. So in this example code, we're going to call a method named updateInt, and we're going to pass that an integer and a double. In our updateInt method, we say that, hey, we expect some arguments to be passed into us as parameters, an integer and a double. And I'm going to take them and do some integer multiplication and return a value. The value I return will be an integer. I set that in my header. So what's important about this method is how this data is passed to us right now. It's passed by value. So in our main method, we have two variables, one called myInt and one called a double. They were each assigned a value, and that value is being passed now as a parameter value into our updateInt method. Now, when our updateInt method receives control, it will actually receive a copy of those values. We will handle those values as the name num and the name multi. While we're working in our updateInt method, we've given them new names, but we are actually working with a copy in memory. So if we were to update those variables in our updateInt method, it wouldn't matter. Those values would not be updated. That update would not be reflected in our main method. The only way we can have updated data sent back to our main method from our updateInt method is by passing a return value. We do that, we did our integer math, and we're returning a value of 24, and our main method is going to save that value in this new integer. So now we have that new value available to our main method. But any other work that we did inside of our updateInt method was invisible to our main method. Our updateInt method was a black box. Main has no idea what was going on there. That's passing by value. When we work with arrays, array data is passed from one method to another by reference, and that means it's passed by memory location. So if I pass an array from my main method into my updateInt method, I'm actually going to be working on the same array in memory at the same location. So a copy of the array will not be made. Any updates that I make to the array within my method would be reflected in the array contents when I return to my main method. So we're working with the same memory location here. So that's a pass by ref. Whenever we're working with arrays, arrays are always passed by ref. So the updates that occur within our method will be available to the caller. We need to be careful about that because it is a little bit different than what we're used to. Now, whenever we're working with the arrays class, we are working with the java.util.arrays library. We are deriving from the arrays class, becoming children of that class. So we have access to all of the methods and the properties of that system arrays class when we're working with arrays. You can see your Java online documentation and of course your textbook for some more information on these often used arrays classes. For example, I could say arrays.sort and then pass in the name of an array, and that would sort the array that I'm referring to. I can use the arrays.fill method, typo, and a few places, huh? That's better. So I can use the arrays class to sort an array. I can use the arrays class to fill an array with a given value. This line of code would fill the name array with the value j. I can use this binary search method of the arrays class to search for the value Jill in an array. Now, whenever we want to work with arrays, there's a couple of things we need to be a little bit aware of. First of all, if I set one array name equal to another array, I am simply creating a reference to the first array. Here's our ages array. The pinkish arrow indicates a reference, a pointer to that array. It's the beginning location of that array in memory. Remember, we said arrays have to be contiguous, so we just need that beginning location, and then we know how to find everything in our array. Now, what if we do perform some code like this, where we set up another integer array called save ages, and we set it equal to or assign it a value of our ages array? Well, we'll create a save ages variable, and that variable's reference will point to the same memory. So we've basically created a new reference to the same array in memory. So no matter how we address the array now, if we were to update index location 0's data of our ages array, the data would be updated in our save ages array. Conversely, if we were to update the data in our save ages array, that update would also show in our ages. They're basically the same thing. They're pointing to the same location in memory. Now, conversely, we can create a shallow copy. And a shallow copy is when we use the copy to method of the arrays class. So in this case, we use the ages array and we copy it to the save ages array. Now each of those data items are copied from the original array to the new array, and we have independent copies. So if we were to execute some code like this, we start out with our ages array, create save ages, and set it equal to a copy of our ages array. We print out both arrays, then change the contents and print them again. We would see that the contents are only updated in the actual array that was specified. Now, another cool thing that we can use is implement the comparable interface. An interface is like a special kind of class. So the comparable interface allows us to override the sort performed by the arrays.sort method. So for example, say we were working with our geometric objects that we worked with a week or so ago in our assignment. We had some circles and rectangles. The Java runtime doesn't know how to sort those kinds of objects. How do you sort a circle? I don't know. Do you know? Well, as a matter of fact, I do, because I created the class, so I could use the comparable interface and create a compare to method and say that when I'm working with circles, I want to compare the area. So I want to compare the area of one circle to the area of another circle in my compare to method to decide which circle is larger than the other. And then I could sort my circles, because now I've said, well, I think I could use the area to do that. I'll try and do that one in another video. Now, we also can have a need to work with a two-dimensional array or a matrix of items, a row and a column type orientation. When we're working with a Java, we are considered row dominant, so it's always our row that's specified first when we're working with a two-dimensional array. So a two-dimensional array is going to have two indexes, a row index value and a column index value. Each of those indexes are going to be separated and set up in their own pair of square brackets. They'll be side by side, and that indicates row, column. We can't switch them. We can't say, oh, Java, I'm going to use column, row. No, it's always row, column. So you can see how this matrix would be assigned index values. 0, 3 would be this cell within our two-dimensional array. We could also have jagged arrays where we have multi-dimensional items. Here's an example of such a thing in our code. We create an array called array name that is two-dimensional, and we say it's a new array of integers, and there are 5 of these entries, and each of those entries is in and of itself an array. And we say that by specifying the empty square brackets. Then we can come back and say array name row 0 is actually a new array of integers that are 3 positions. So now we have 3 entries there. And the same way we could say that array name row 4, this row here, is a new array of integers, and there are 5 occurrences in that entry. So jagged arrays can be harder to visualize, but they can be pretty handy for us to use in our code. So arrays really are awesome. They allow us to manipulate repeating data elements efficiently. Arrays can be handled really well using for loops. The for each statement, or the enhanced for loop, allows us to easily process all of the entries in an array. And it's really important for you to get a lot of practice working with arrays. They're used very often. So the REPL that you have this week assumes that you'll be looking at the textbook while you go through it. So please don't try to do it cold turkey. You need that textbook help, I think. It'll make a big difference. So do not, torture yourself by doing it with no resources whatsoever. Let me know if you have any problems, and I hope that this was a good summary for you on arrays. Thank you.